And our very first talk is Evolution of Application Security. Those who don't know history are destined to repeat it. Our speaker is Louis. Louis is the founder and director of pentesterlab.com, which is an innovative penetration testing and application security training platform trusted by many industry professionals. He has over 15 years of experience in information security and has worked in many technical information security roles, both as a consultant and on internal teams. Louis is a sought-after speaker and trainer. Before we start with the talk, I'd just like to say that please add in any questions that you have in the Q&A, and please do take coffee and tea breaks. Please feel free to have coffee during the talk itself. All right, let us get started now.
Oh, hello, I didn't see you there. Hi, my name is Louis, and I'm a teacher. And I teach web security, application security, and mostly hacking. How to hack into web application. I do that on a website named pentesterlab.com, and I've been doing that for a few years now. When you are teaching hacking, web security, and how to break into websites, what you need is realistic examples of vulnerabilities. For this reason, and because I really love Ruby and really love Ruby on Rails, I've been looking at the security of Ruby on Rails for years, pretty much since I started using it in 2008 or something like that. There are a lot of things to learn from all those years of Ruby on Rails. A lot of talks are focusing on teaching new techniques, new vulnerabilities, and new things. But I thought, surely we can learn a lot from all those years of Rails security. Because when reviewing new code, new libraries, I can see the same vulnerabilities that I saw in Rails a few years back. So let's jump in and see what we can learn from all those years of Rails security. Ruby on Rails is used by a lot of organizations: GitHub, GitLab, Fiverr, Airbnb, Shopify. So there are a lot of companies who have interest in the security of Rails. Over the year, the security of all these companies were tied to the security of Rails. Now, one way to study the security of applications or frameworks is to look at their CVEs. If we look, for example, at the number of CVE per year for Ruby on Rails, we can see that the number was pretty low until 2011, a lot more vulnerability in 2011, 2012, and 2013. And since there, it went down until 2019 to go up again in 2020 and 2021. The number of CVE doesn't tell you the story behind the vulnerabilities. It's only a number, and you don't know if it is because the code is less secure over time, more secure over time, or it's just more people looking at the code, less people looking at the code. It's hard to rate the security of an application just by basing your study on the number of CVE. Another idea could be to look at the number of code execution. Surely, if there are code execution in a code base, this must be really insecure. And we can see that Rails had every 2 or 3 years a code execution vulnerability. Is Rails a terrible framework? Is it really bad and really insecure? I don't think so. Because again, the number of code execution doesn't really tell you the whole story. There are bugs that are code execution without any user interaction in a default configuration, and there are bugs who are code execution with user interaction if and only if the developer used some specific code or specific function or method. And the number of CVE or the number of code execution doesn't really tell you that story. Another metric could be to look at the sum of the CVSS score. As security engineer or security professional, we use CVSS score to tell the world how bad a security issue is. The higher your score, the worse it is, and you can go up to 10. If we sum up the CVSS score of all the CVE for all those years, we can see a very similar trend for Ruby on Rails, with again 2013 not being the best year for Rails. And we can see that it's coming again. So maybe 2022 will be even worse than 2013. And again, the CVSS score, even if we sum them up and they are supposed to take into account everything about the vulnerability, it doesn't really tell you the whole story. It's supposed to, but it doesn't. And if you do a lot of code review of Rails, you will see that the recent bugs in Rails are not as bad as the one we saw in the past. And that's what we're going to look into. Another idea could be to average and do a max CVSS. And we can see that over time, the values are pretty much the same. There is no big trend of the bugs are getting worse over time or the bugs are getting better. Again, we can see that 2013 wasn't a great year for Ruby on Rails security, with a CVSS of 10, which is the worst value you can get. Interestingly enough, that's in 2013 that Rails started their bug bounty, in December 2013. So it was after this year of bad bugs that they started the bounty. Between December and the end of the year, there were only 4 bugs submitted to Rails. But with bug bounty, you never really know when they actually started or when things got eligible, so it's hard to tell. But it seems that starting a bug bounty is not the reason why they got so many bugs in 2013, based on the report. However, that's probably the reason they had 57 CVE between December 2013 and now. Because often with software, when a lot of bugs are discovered, people start thinking there isn't anymore. Like, it dried out. There's no bug to find anymore. That's what I like to name the SMB effect. Basically, back in the day, SMB, Windows SMB, got so beaten up by security researchers that after a while people stopped looking at it because everyone had. And they thought there were no longer bugs in SMB. Then Laurent Gaffey came along and found a lot more bugs, just because people stopped looking. This didn't happen with Ruby on Rails, because they started their bug bounty just at the right time, and people kept searching for bugs and find more bugs. So that's where they got lucky, because if people stop looking, you can be sure that bugs will not get discovered and be missed. With all these metrics, what I'm trying to demonstrate is that it's really hard to rate the security of a framework or the security of an application just based on the history and few CVSS score. A way better matrix would be to look at how much time it takes them to fix a vulnerability from the moment it got reported to the moment it is fixed and the fix is available to everyone. Your ability to patch vulnerability quickly or provide a patch for vulnerability quickly is key when you are talking about application security. And it's probably one of the key metrics you should use when rating a project. Now let's move to security feature. Ruby on Rails, in its early version, was using a classic server-side session mechanism. Basically, the framework or the application provides client with a big number. When the client connects back to the application to retrieve information, it passes this big number as a cookie. This big number is used as an index in a lookup table. In 2007, Ruby on Rails developers decided to move to signed session. Signed sessions are a great mechanism because they allow you to easily scale across data center, across multiple servers, or across multiple availability zones, because you don't need to share a file system or a database or a cache. You just need to share a secret. The secret is used to sign the session. If you don't have the secret, you cannot sign the session, so you cannot tamper with it. So in 2007, Ruby on Rails developer decided to move to that mechanism. And this is the code that was used in the first patch. First, we can see that the developer is using marshal.dump. They are using the Marshall format to serialize information. Then, what they do is provide the data, that is actually the session that goes through Marshall dump that goes through base64 and code64, and they generate a digest for it. If we jump to the generate digest function, we can see that we compute a SHA-12 of the data and the secret. We concatenate the data and the secret, and we run SHA-2 on top of it, and we get the X digest. If you are familiar with crypto, you know that that's probably not the right way to do it, but we will look into it when we see the next patch. Another issue is located in the function used to load the cookie and get a session. What we do is we split the data based on the 2 -- sign, then we generate a digest and we compare it with the signature. We can see that we're using a double equals sign, which will allow us to make sure that the two values match, but we'll also create an information leak. We are going to leak the time it takes to make the comparison. If the comparison is done really quickly, we know that the digest and the computed digest are very different. If the comparison takes a bit more time, we know that the digest and the compute digest start with the same thing. And the more time it takes, the more similar the start of the digest we provide is to the digest computed by the application. And that allows us to brute force a valid digest for the data we provided. Quickly, this code was changed. A few weeks later, to avoid length extension, even if the order of the argument wouldn't allow exploitation of the bug, they changed the code from using SHA-512 to using HMAC with SHA-1. We know that now SHA-1 is not ideal, but you need to remember that it was in 2007. They probably made that change to avoid length extension. Even if the current pattern, data followed by the secret, is not exploitable with length extension because you require the secret followed by the data, it's a way better construct to use HMAC of SHA-1 than just a pure hash like SHA-512. If we keep going and keep learning for more changes, we can see something that is still very rare to see in library used to sign data. Let's say, for example, you review JWT libraries on a regular basis, you will very, very rarely see this kind of checks. Here, the developer added a check to make sure that the key, the secret used to sign the session is not blank. And that's very important because if the secret is not set, you're going to sign with an empty string. And you need to remember that breaking that secret is really simple for an attacker. You just need one valid session, and then you can spend days, week, month offline trying to crack it. And then, once you crack it, you can sign your own session and become, for example, another user. And the server will only see two requests, the one to get the initial session and the one with the other users. So that's why the secret here is very important. And the strength of the signature is basically only based on the strength of the secret. And to make things even stronger, in the following version of Rails, so in Rails 2.1.1 that was released a few months after this, they even set a minimum length check on the size of the secret to make sure it was long enough. And they required people to set a secret of at least 30 characters. This prevented people from using a secret with the value secret or password 123. And if you work in security, you know how common those are. But We still have in version 2.1.1 the same security issue with the non-time constant comparison of the signature and the computed signature. This will be fixed in 2009 with CV 2009-3086, where they introduce the method secure compare that provides developers with a way to compare signature in a time constant way. Regardless of how different the two signatures are, it will take the same time for the framework to compare them, as long as we can see here that they are the same size. With Rails 4.1, the Rails developer made the serializer JSON available. Instead of using Marshall to load and dump data, they start moving to JSON. JSON became the default serializer, and they also provide an hybrid mode to be able to easily move from Marshall to JSON over time. The serializer hybrid was used to load the data in JSON or load the data in Marshall and then create new session with the same data as JSON. They made that move because a lot of applications leaked the secret used to sign the data, either because this secret was shared or this secret was published on websites like GitHub, or the secret was, for example, shared with every instance of an open source project. Imagine installing a Ruby on Rails application and forgetting to change the secret. Someone installing the same application will have the same secret as you and can use that secret to forge session. Then they can just forge a malicious Marshall payload that will allow them to gain code execution on your server. That's why moving from the Marshall serializer to the JSON serializer was critical. If you work in application security or as a DevOps engineer, you know that one hard problem to solve when deploying application is how to manage secrets. In Rails 5.2, Rails start providing developers with a simple way to store secrets. Basically, with two files. One storing the secret, and this file is encrypted, and you can keep this file in your Git repository. This way you have versioning for free. And one file named master.key that is used to decrypt that file. You don't commit the master.key, you only use it on your production server or keep it in a safe place. This way, anyone with the master.key can change the secret and update the secret for this application, but people without the master.key will not be able to access or modify the secret. This allows people using Ruby on Rails to have versioning of this secret without people knowing what the secrets are. And you will store the secret inside your source code, but they are not available to anyone with access to the source code. And as you know, retrofitting secret management to an application that hasn't been built with secret management in mind is really hard and complex. That's why having this for free, thanks to Ruby on Rails, is a real gift for your developers and your SecOps team. In Rails 6, Ruby on Rails developer even added a way to simply manage different credentials for different environments. Where are the bugs coming from? It's always important to understand where all the bugs are coming from. So let's look at a few patches. First, we're going to look at the first one, CVE 2006-4111. We can see first a change in regular expression, purple being the old version and light blue being the new version. We can see that first, we're changing a regular expression to swap caret and $sign with \a and \z. This is probably the biggest Ruby regular expression gotcha. In Ruby, you need to use \a and \z when you want the start and the end of the string. Caret and $ are used for the start and the end of the line. And this regular expression issue that was found in Rails in 2006 has been repeated since there in every single Ruby on Rails application, because that's a very common mistake and that's a very big gotcha. So if you had looked in 2006 at the patches from Rails, you will have learned that regular expression in Rails need to use \a and \g when you want the start of the end of the string. Otherwise, people can just inject new lines and bypass your regular expression. If we look a bit down, we can see that eval has been replaced by const get to avoid taking a string from the user and calling the method eval on it, because eval allows an attacker, if they control the input, to run any code they want. And that, with the buggy regular expression, allow an attacker to gain remote code execution. And that's what the vulnerability was for this CVE. So something pretty severe. Back when I was learning to write web application at engineering school, one of my teachers used to say, eval is evil. Try to avoid using it at all costs. And I think that's a lesson that really pays off when you're doing security. You may want to be smart about your code, but you're always only one mistake away from people injecting code and gaining code execution on your server. So if you can avoid it, don't use eval. And again, if you are using a regular expression, make sure you're using \a and \g instead of caret and $, because those can be bypassed using a new line in Ruby. Another patch, this time from 2008. And in 2008, one attack that was pretty common was response splitting, because a lot of web server, application server were vulnerable to it. Basically, you were injecting a new line or return carriage in a parameter, and this parameter was used as part of a redirect. By injecting a new line, the server will add the new line, and this will allow you to add content to the response or extra headers to the response. Here we can see that with this patch, they remove \n and \r, so new line and return carriage, and they replace it by an empty string to prevent this attack. At the same time, they patched a cross-site scripting by calling cgi.escape.html. A cross-site scripting in a redirect is often not exploitable, but still a good way to fix two bugs and kill two birds with one stone. Another interesting bug was in 2012, and that was CVE 2012-2661, and an active record SQL injection. The really interesting part is Rails as a framework provide prevention against SQL injection since the very, very early day. But this vulnerability introduced an SQL injection that could be used to dump all the database. It was actually pretty tricky to exploit it, and I think me and my coworker Luke at the time were the first one to release an exploit for it. Basically, the issue was in the way URL parameters were handled by active record. If you had code taking a parameter from the URL from the user was able to change, for example, ID equals 1 to a hash and provide ID as a hash to the application. The application was then using that hash instead of this string or integer, and this will change the behavior of active record. And this will allow you to trigger an SQL injection. The most interesting part about this bug was that it wasn't simple to exploit because there were actually two SQL queries. One that was retrieving information from the database to know what the table looked like, and the one that was actually making the query. The injection was in the first one. And the problem was that Rails was pretty smart about it and was caching the result. So you had to provide a payload that was unique every time to prevent Rails from caching the data. It looks simple on paper, but it's actually a bit trickier than most SQL injection. And so you were able to inject in a show query, despite the difficulty of the exploitation, like most SQL injection, this issue allowed you to dump the entire content of the database. When we looked at the worst year for Rails, 2013, we discovered that there was a vulnerability with a CVSS score of 10. Rails applications support XML requests, and they parse it as any other format, like they do with JSON, like they do with URL encoded data. And a researcher realized that instead of passing XML to the application, you could pass XML with YAML inside of the XML. And we can see an example here in the exploit we are looking at. Here we can see that the Ruby code, here named Ruby, can be replaced by any valid Ruby code and will be executed by any Rails application receiving this request, leading to code execution. This payload in YAML is dependent of the Ruby on Rails internal object, but in 2018, a researcher named Luke Junkie published a YAML payload that didn't even rely on Ruby on Rails internal and was allowing him to gain code execution on any application using YAML.load, making this vulnerability even worse. Let's look at CV 2016-2098 to see how this is a bit different from the previous CV 2013. Here, we also have a risk of code execution. However, not every single Rails application is vulnerable by default. You need to have code that looks like the code we can see here, with a render and a parameter coming from the user. And if we look at the payload used to trigger that exploit, we see that we provide an ID parameter, but instead of passing just a string, for example, with page or something like that, we need to pass it as a hash. And we will use the keyword inline that for Rails and for the render method will tell Rails to load the value as code and execute it. So instead of looking for a file on the file system, inline will allow an attacker to just provide the malicious code they want to run. And that was instant code execution for anyone using the code pattern we saw before. But as an attacker, you will have to find the right action, the right controller that uses that code to be able to trigger your code execution. Really interesting from 2 years ago was CV 2019-5418, where this time the vulnerable code looked something like this. You had to use render with a file, but we can see that the attacker doesn't have any control over anything in that code. There is no params, there is nothing that the attacker controls. If we look at the payload, that gives us a better idea of what the issue may be. Here, with curl, we're passing a header accept with the value ../config/master.key. Master.key is a file used to encrypt the credentials in modern Rails application, and 2 curly brackets. And then we pass just the URL of our server with the action info, because we need to attack the right vulnerable pattern, and we just saving the key as master.key. The issue was due to the fact that Rails tried to be smart and provide the right format based on the accept header. If you accept text HTML, Rails is going to try to respond with HTML. If you request JSON, Rails is going to try to reply to you with JSON. To do that, Rails was using a dir glob and concatenating the accept value to get a list of potential valid files. However, Rails developer forgot to properly escape or filter the value provided, which allowed an attacker to provide a malicious path with .. to access other files. However, what the CVSS score doesn't show really well is that this exploit in production was a one-shot. Due to Rails internal caching of Vue to be able to render Vue faster, and since an attacker doesn't control anything here except from the accept header, Rails would cache this response. So you were only able to access one file once. As soon as you tried this attack against a server, it was finished. You had to wait for the server to restart, to crash, or the application to be redeployed. And that's something that we can't really see when we just look at the CVSS score. That's why it's so important to carefully research vulnerabilities and see how they work to be able to really assess the risk presented by an adversary. At the exact same time as the vulnerability CVE 2019-5418, another vulnerability, CVE 2019-5420, was published. This vulnerability was only impacting Rails dev and test environment. By default, Rails provides three environments: development, test, and production. In production, the secret is created by the user and stored in the credential store. In development and test, until this vulnerability was published, it was generated based on the name of the application by using an MD5 of the name. This will allow someone to easily brute force the key used to sign session in development and test. It didn't impact production, but too often organizations have Rails application running on the internet without any filtering in development mode. This would potentially allow someone to forge a session to access the development mode application and trigger unexpected behavior. Since an attacker could sign their session, and depending on the serializer used by Rails, they could potentially gain code execution by loading a malicious Marshall session. The impact for this vulnerability was pretty high, and that is reflected by the CVSS score, but the risk was pretty low as there was a lot of condition to be able to gain code execution using this bug. And that's why CVSS score don't always reflect the reality of what a vulnerability is. And we see that here they patched the vulnerability by creating a new method that will generate a proper random secret for development mode. Now let's look at an even more recent vulnerability in Rails, CVE 2020-8163, where here we can see an example of vulnerable code. Again, we need to have code that looks like this pattern to be vulnerable. And this pattern is, fortunately or unfortunately, if you're an attacker, pretty rare. However, the CVSS score doesn't really reflect that. If we look at the vulnerable code, so not an example of the code, the actual vulnerable code from the Rails source code, we can see that we have this function locals code, where we're going to use the key and the value to generate all a string that will contain all the assignment to make sure that these key and value are available in the scope for the render. If we keep looking deeper, we can see that we're using that as part of the creation of a big string that define a method, and then this big string, this source, goes through module eval, which is just a variation on eval. And as we saw, eval is evil. If we look at the patch, the solution for a Rails developer was to add a filter to make sure that no special characters were available in the key. This way, an attacker couldn't inject a malicious value. If we look at the payload used to trigger that vulnerability, we can see an example here based on the code we had before. We're providing a value equals 124. This is just a dummy string. Then we have the actual malicious value. This is a parameter name, and its value is 123. We can see that it's first an AND, followed by a new line, followed by backtick a command, then another backtick to finish a command, and a new line and underscore end. If we parse that like Ruby will do, we get this nice hash for params, and when Ruby on Rails will load that value and generate a string from it, it will actually first end the current method to allow us to put more code, then run the command we want to run thanks to the backticks, and then use underscore end to make sure that everything after that code is not evaluated and doesn't trigger any syntax error that may prevent our code from being executed. And that will allow you to gain code execution on a server. But again, this only works if the application has the right vulnerable pattern. Another thing worth looking into when you are about to pick a new framework to develop as a developer is the type of advisory you will get. Here we can see an example of a Ruby on Rails advisory. It's a Ruby on Rails advisory from a recent version of Rails, so it's probably a lot better than they used to be. However, it's an extraordinary example of what the perfect advisory looks like. First, we provide a little bit of details about the vulnerability. Then we moved to the fixed version. Quickly, we know what version are fixed. This allows us to know if our version is vulnerable or not. Then we have an example of vulnerable code, because not all code or not all application may be vulnerable. So here we have the perfect pattern that explained us what we need to look at as a developer or a security person to make sure that our code is or isn't vulnerable. Finally, the Ruby on Rails security team provides a lot of details on how to mitigate the issue, either by modifying the code or by monkey patching the code, or finally by applying one of the patches available. And we can see that they provide a patch for the 5 latest versions of Ruby on Rails. If you need to write advisory for your open source project, you can look at what the Ruby on Rails security team has been provided for a long time now to see what a really good advisory looks like. And you can take inspiration from it. And this is it for this talk. I hope I managed to convince you that looking at the security history of mature project is a really good way to learn more about application security and to learn how to find bugs in new code base or to find good practices that you can apply to code base you're working on as a developer, as a reviewer, or as a security person. Thanks for your time, take care, and stay safe.
Thank you, Louis, for such an informative talk. We are now open to questions. Any questions that you folks have, please drop in your questions in the Q&A section and Louis can answer them live. Okay, we'll wait for 30 more seconds to see if we have any questions. There is one, Louis.
Where we are. Thanks for the kind words on the chat. So like a lot of people are still using Rails, like Shopify, GitHub, GitLab, and I don't think like the problem is that with people moving to microservices because monolith are not cool enough anymore, you don't see as many Rails applications because I don't think Rails is a good tool to build microservices. or even if you use the Rails API, it's pretty heavy, and people prefer like writing code in languages that no one will be able to maintain in 5 years. So that's why you don't see a lot of Rails anymore, or not as much as it used to be, but still a lot of like big company running on Rails and pretty happy about it. So yeah. Yes, I see another comment. Yeah, reading code is really important. Like if you're a security person and you want to make sure you're going to have a job for the next 10 or 15 years, start reading code on a regular basis. Like it's probably the skill that people will need the most in the few coming years, because people will realize that having a pen test report doesn't give them a lot of value, but having someone who can read diff, can look at patches, can send you like even test cases is extremely valuable. So yeah, code review is probably the next big thing, I think, for people working in application security. Or has been the next big thing for people working in application security, and will stay one of the big things.
All right, if you don't have any more questions, we are going to launch a quick poll for the feedback. Please add in your feedback. There are 4 questions.
No, so someone asking a question about Pentester Labs or the website I run. No, the labs are not community driven. Until now, I wrote all of them, and I think that's really helps keeping this as a teaching platform instead of just like as a hacking online platform, and that's what I like about it. But I'm getting people to help now with it, but not community driven at the moment. And yeah, I will be on Discord for the next few minutes or more if there are many questions. So don't hesitate, or just reach out on Twitter or LinkedIn or whatever you feel like. Yes, so I got a question. Any static code analyzer can be used for security review? So I think you have a lot of code analyzer that can be used. It depends on 2 things. So where you're going to use them. So you either go with the commercial, let's say the huge commercial tools like the main ones. Let's not see them. And the problem is that they're going to take a lot of time and you're going to have a lot of result. Or you try to be more hackish about it and you look at tools like CodeQL or SemGrep, and you use those as a way to augment your capacity. Basically, all the big commercial tools are here to say, okay, we have someone who doesn't know how to do code review, and we're going to point them to where the bugs are. The new cool code review tools like SemGrep, like CodeQL, are more a way to scale up your capacity. You say, I have this pattern in my source code. I know it's vulnerable because I found it. I know that my developers are likely to do this mistake. So I'm going to write a rule to say this is what the vulnerable code looks like. And now I'm going to look at it at scale. So yeah, and there are plenty of code analyzer. I'm sure like if you search for like SAST, you're going to find a lot of responses and a lot of, and you're going to have like Google ads for the next 2 months to buy their product. So yeah. I got another question. Is there any way to discover vulnerability in application without prior knowledge about the application? Yes. So without any prior knowledge, you can just do like what people have been doing for a long time now, is just pen testing the application. Then if you are lucky and you have access to the source code, you can go further, but just just trying like every single input and put like special characters and things like that will give you like a lot of, if you're lucky, a lot of bugs. And now the shift is more to code review, because with applications that are mature, it's unlikely that just putting like special characters in a URL will give you bugs, because these code bases are mature, so all the low-hanging fruits are gone. So that's why you need to go to a more like internal view of the application. And if you are like buying security as an organization, you probably want to give people access to your source code, because they're going to be faster, they're going to be more efficient, and they're going to find more bugs. So yeah, you can definitely find bugs without prior knowledge of an application, but if you want to be efficient, it's a lot better to have access to the source code. I got a question, another one. I was a developer, now moved to the AppSec and interest to take up some industry standard certification. Can you recommend some relevant certification, or is it worth taking certification? So I'm probably the worst person to ask this question. I'm pretty against certification. I think they're good if you want a reward, but for the industry as a whole, they just are the wrong incentive. If you want to show that you have progress, it's good, but too often certification are now used by HR to say, okay, we want certification ABC, and we're not going to look at resume of people who don't have this certification. And the problem is that people who have the money, the time, the mean to take this certification, it's all right for them. It's just like, okay, I got like this $2,000 certification, and I'm going to go through HR without any problem. But people who are not that lucky, like they just like, there is this big like gatekeeper of the certification. So that's why I don't encourage people to do that. I think creating content or reviewing content is a way better way to like find a job. Like just look, like this talk is nothing complex. It's just like I spent a few hours looking at patches over a few years, so because I knew about them. But like if you keep looking at patches and creating content, maybe a blog post explaining what the bug is, explaining how they patched it, why it works, you will learn a lot more than a certification. And I think that's a lot more marketable, and people will like that as well, because you're different, you stick out compared to other people. And that's why I try to not encourage people to get certification. And yeah, it's good, like if you can afford it, do it, because it's fun. And yeah, but like I don't think they're good for the industry. Any specific security area we should focus while developing an application using such technology? So when you're developing application and more and more bugs are due to two things. Either the application is automating some stuff and you don't know about it, and this has some bugs. Or another common things with, to go back to microservices, is the issue in interactions between components. Let's say you have two microservices. What is the trust relationship between them? And can someone find a way to break this trust or inject something that will change the behavior in the way things are parsed or managed? So I think that's a good way to focus on this, because now with modern framework, you got anti-cross-site scripting, anti-SQL injection. So everything that the framework or libraries give you for free is probably not something you want to look at. JWT tokens are really good and really fun to look at. Okay, more question. What's your take on red team roadmap? How is the person? We're gonna run out of time.
Yeah, I think we can, folks, we can take the questions on Discord. We've also shared the Discord.
I will type the answer. Yep.
So yeah, that would be great. I think we'll just move on. But I think this was an awesome session.
Thanks a lot. Thanks.
Okay.
Thank you for answering the question with so much of patience.